Good evening. Good evening to the audience who have come on this Saturday to listen to Mr. Mukund Joshi. We welcome you all on behalf of QCrete India. And also, we are welcoming you all on behalf of Indian Country Institute Mangalore Center. Mukund Joshi needs no introduction. He is very popular because he is very much involved and engaged in spreading awareness on concrete matters. Many subjects of concrete he is continuously engaged. He has his own YouTube channel, and he has his channel has been viewed by more than 1 lakh people. I will just go through a very small introduction about Mr. Mukund Joshi without wasting much time. Mr. Mukund Joshi is MD of Constor Solutions Limited, Nasik, and he has huge professional experience in leading design, erection, and operation of a multi-million-dollar AAC business. He has administered, executed many AAC projects which involved development of idea, constant interaction with contractors, project management clients, and other building professionals. With a solid experience of about 7 years in Middle East, in the concrete technology and project management in Bahrain, UAE, Saudi Arabia, Kuwait, Oman, Qatar, Iran, Libya, between 2002 to 2010, he has done many projects. Currently working as technical advisor, very important to several companies. Some of them which we can name here is Tata Steel, Sharda Steel, Godrej Construction, training their staff, designing concrete and educating on AAC. And he has been the author of a very well-known book, AAC Blocks for Superior Masonry Construction, and it is available on Amazon, published in 2019. He has been honored with fellowship by Maharashtra Fly Ash Information Center in 2007, and he is very proficient in many aspects of concrete, durability, self-compacting concrete testing, and as we already told, he's master really in subjects like AAC, etc. And he has been continuously giving consultation, etc. on AAC blocks. And the list is big, and he's in short, I'm just telling about his Bachelor of Construction Engineering from Mumbai University. He's a certified internal quality auditor, associate member of Indian Institute of Concrete Technologies, City and Guilds, London. And he has worked also in many companies like Global Foundation Bahrain, Dirk India Nasik, where he was working as Director Product Technology, Deckroff and Widman AG, working as Concrete Technologist, and he has also worked as Quality Control Engineer in Mahindra Consultants India, 1993 to 96, and he also knows other than Indian languages, German language, where he has worked when he has worked in Germany. And as we said, he has his own channel with 2,000 subscribers, and he has already reached 1 lakh views. And with this short, I can say brief introduction, I welcome Mr. Mukund Joshi. Most important thing about Mukund Joshi is willing to train people. Most important thing which I want to tell here is he is willing to train people. He want to build the awareness on concrete technology. With this, we are thankful to you, sir, for giving your experience on this forum on behalf of QCrete India Private Limited. Thank you. Welcome, sir. Please.
Kaushik sir, thank you for such a long introduction, and I welcome all our participants today in the session Inside Story of AAC Blocks. So let us go to the next slide and see this exciting journey of AAC Blocks. So can we go to the next slide? Anjali ji, can we go to the slide, please? So friends, the story begins of AAC Blocks with the very words AAC, and a number of times I have seen that people mistakenly say ACC Blocks, right? But ACC is a cement company and we are talking about AAC Blocks. So what do we mean by AAC? We will begin with that. Then we will look at the manufacturing process of our AAC blocks. So how do we make these blocks? Why they are so special, and why they were invented? So look at all those aspects, right? And then we will go look at the testing of blocks, whatever IS code is saying about our AAC blocks. And finally, the most important part is the execution, using the blocks on our construction site, and that is a key aspect. So because this is a new age material, and well, we are here to our first slide. Technology is strange, sometimes it works, sometimes it throws a googly at you, and then you have to find a way out. So we have covered this slide, Anjali ji. Let's go to the next slide. Thank you. Friends, you all were shocked yesterday when we heard about Russia entering Ukraine and the war began. So same thing happened in Europe at the time of First World War, and unfortunately there was a lot of destruction. After the World War ended, Europe wanted to have a building material which would really help them build their houses, which will keep the cold outside. So they were looking for a building material, and this Swedish architect cum scientist, Mr. Ericsson, he invented this aerated concrete in the year 1920. So their purpose was what? To keep the cold out of the house. What is our purpose? To keep the heat away from our home. So the purpose is same, thermal insulation, and this product was invented to give a very high level of thermal insulation. We will go ahead and see how it happens, right? So this product gained popularity in the Europe because of its lightweight nature, because of the thermal insulating properties, and by 1935 already there were so many plants all over the Europe producing AAC blocks, selling them, and people using them. So this is not a new product, although in our country we feel it has come since the last 10 years, but in the world it is there for more than 100 years. We are here 2022 and this product was invented in 1920. So this product entered in India in 1970 when BG Shirke from Pune, who is a government contractor even today, and he went to Sweden, and Mr. Shirke got this Swedish technology Siporex to Pune. Now they also have a plant in Bangalore. So Siporex is still there, but the initial few years from 1970 to almost 2010, 40 years, BG Shirke was a government contractor, and he got the product approved for government tenders, and lot of government construction, we call it Sidco construction in Maharashtra, was done with AAC blocks. The roofs were done with AAC panels. But friends, this product never went to a private builder. So there was no one who would, a marketing person, a sales guy, who would take the product, to a builder, explain the benefits and convince him to use it, show the cost analysis. There was no one to do that. So although Siporex is working in Pune since 1970, only when other guys entered the market, like HIL, Hyderabad Industries Limited, Ecolite from Pune, QCrete from Surat, our own company Constro Solutions. So when number of private players entered after 2008, it started happening, and particularly since last 10 years, there became a sudden boom in the market when the private builder, he understood the benefits of the product. So let's go to the next slide now and look at how this AAC is manufactured. So Anjali ji, let's go to the next slide, please. And we will see that how this name AAC has come and how we manufacture this product. So can we go to the next slide? So friends, the first A is autoclave. You see this green vessel, this long green vessel. So this is an autoclave in which all the blocks are put inside, the doors are closed, and you give very high temperature steam, 200 degrees centigrade for 12 hours of period at a pressure of 12 bar. So it's a very high pressure, and with this huge steam, you are actually cooking the blocks inside, right? We all civil engineers know that strength of concrete is a function of time and temperature. During the winter season like this, we know that the de-shuttering gets delayed. We can't do the speedy construction as we do in summer. There is a small delay. Why? Because the temperatures are low and the strength development also becomes low. So the strength development of cement is a multiplication of temperature and time. So if you increase the temperature to 200 degrees like this autoclave, that 28 days strength of your cement, you can extract it within a 12-hour period. Many of my QC fellows, friends, they know that we do accelerated curing in our batching plant just to predict the strength what we are going to get, right? So what is accelerated curing? You give heated water to your concrete cubes and we get the strength. So that's what we do. So basically this autoclave is nothing but a big pressure cooker, like it is there in your kitchen. Like we make dal chawal in our pressure cooker, it is exactly same given the steam, but at our home the pressure is very small pressure in the pressure cooker. It is just 0.5 bars, and here it is 12 bars, so 24 times higher pressure is given, and therefore there can be safety hazards with an autoclave in case something wrong happens. You might have read 2 years ago there was an accident in Gujarat in one of the plants, and unfortunately few people died. So that is what autoclave does. It gives you the strength in 12-hour period, so that you don't need any more curing. You don't have to keep the blocks in the yard, spray water, nothing. Just leave them for 24 hours so that this 200-degree temperature slightly comes down, and then you can dispatch them. That is our first A, autoclave. Second is aerated. So this is an aerated product. If you see a broken piece of AAC block, and if you look closely, you will find there are millions of air bubbles, size less than 2 millimeters. So this aerated structure, aerated means what? Anything in which you have put the air inside, like the idli that we eat in the morning, right? So we keep the idli ka batter overnight, and what we see, it rises, it swells, it expands, and the same swelling, the same aeration is created in a AAC block plant. So by creating this aeration, what we are doing, we are introducing hydrogen gas inside the mix, which creates this aerated honeycombed structure. So if you look at all those air pores, you will find that each pore is like a cell, like a honeybee house. Have you seen a honeybee house? Madhumakhi ka ghar, right? So how there are cells in it, right? So exactly in the same manner, this cell formation takes place in a AAC block, and therefore our IS code calls them not AAC. What does it call? IS code 2185 part 3, it calls them cellular blocks. So the blocks which have got cellular structure. So each cell, which is less than 2 millimeters, is separate from the next cell, separated by the AAC material by very thin wall, and therefore there is no capillary action in AAC. This means if you put water from one side, it will not come out from the other side, right? So it prevents the capillary action, which is very much there in our red clay bricks. But we'll speak about it in few minutes more. So this is what the hydrogen gas does. For that, you add a reagent called aluminium powder. This aluminium powder reacts with calcium hydroxide and liberates hydrogen gas and makes the product aerated product. So you have seen this aluminium powder, you have seen it. You know where it is? It is in our Diwali crackers, the atom bombs. You know that silver powder, that is the aluminium powder. So it is another hazardous material which you have to handle carefully at the plant. One is autoclave and second is this aluminium powder. So what we do is we create a mix, we add aluminium powder, the material starts rising, and just within 40 minutes you get double the volume. So we have molds, you fill up half the mold, and in 40 minutes the mold comes to the full top level. So why? Because of the hydrogen gas, because of the cellular structure, because of aeration. That is our second A. Autoclave, aerated, C for concrete. But you will say in this concrete there is no sand, no aggregates, still we are calling it a concrete. Yes, this is a concrete made with aggregates called fly ash. Why fly ash? Because fly ash is light in weight. That is one advantage, and you want to make a lightweight product. Second benefit is fly ash also has got reactive silica and alumina. 65% of AAC block contains fly ash, and remaining 35% you have got cement, you have got quicklime, you have got aluminium powder. So that is how we make AAC blocks. And let us go to the next slide and see, once we get the AAC block, how do we compare it with our existing products. So can we go to the next slide? So possibly there is a small delay because we are in a live webinar, and it happens that a delay of 8 to 10 seconds is maintained. So I will try to give instructions slightly earlier so that we can move to the next slide. Anjali ji can operate it and go to the next slide. So let's go to the next slide and see that mankind has been using red clay brick since 5,000 years now. Mohenjo-daro excavation, if you see, we still get the same brick which is there today, same dimensions, same properties. So the whole world changed, you know, and we came to using mobiles and internet and everything. But the red clay brick does not change. It did not change. It remained. Why? Because it was a good product. It had certain properties. You can do it in a very cheap cost without spending much money. The red clay brick can keep the heat away. And this is a slide which tells us about the comparison. So the first point is the strength. Now clay bricks, we know how they are. At one taluka, you will get very high strength, and adjoining taluka, you will get very bad quality. So the average strength of red clay bricks moves between 2.5 to 3.5 or 4. So in strength, when you ask for AAC block, you get a very consistent product, which is 4 Newton strength. The second most important reason which is coming from our aeration is density. Density means what? Weight. Let's not get confused because of the big words like density. Just weight of brick is 2.5 times more than weight of AAC block of same size. So what happens because of that? Your whole construction becomes lightweight. Lightweight doesn't mean low strength. So it is high strength construction but low in weight. Now this is a partition wall, right? What is behind me? Now why you want to increase the weight of this partition wall? This is not a load bearing member. We are all staying in RCC homes, right? So they are just for partition purpose. So when you reduce the dead load of building by using AAC block instead of a brick, suddenly the dead load is reduced. So this means you need less reinforcement steel, less concrete section, and the construction becomes cheaper. Also, because of this lightweight construction, the construction becomes earthquake resistant. If you go to Japan, 70% of construction is in Japan is from AAC blocks, lightweight construction. We all know lighter the construction, more stable it is in case of an earthquake. So we reduce the density of AC blocks, we reduce the weight, we make it lightweight, we reduce the construction cost, we make it earthquake resistant, and we also make it thermally resistant. So if you go to the thermal conductivity point, which is written here, you will find that for red clay brick, the thermal conductivity value is 0.9. What does it mean, 0.9 value? So if I increase the atmospheric temperature by 1 degree outside, the heat inside will increase by 0.9 watts. So thermal conductivity is measured in watts. How much heat is coming inside? So the value is 0.9 watts per degree Kelvin, per degree change, per meter. Okay, per meter thickness of our wall. Now the same value for AAC blocks is just 0.24. So it is almost 4 times more powerful in stopping the heat from coming inside. So that is another big benefit coming from AAC blocks. So if you will stay in a AAC block house, you will have very comfortable stay even during summer, and it also brings down your energy cost, your air conditioning cost. Okay, now we will go to the next slide. In the meantime, also we have to see at the joint thickness. So because it is a factory made product, it is perfect in size and shape, you need a very thin joint, and not like our clay bricks where the shape is completely irregular. You put a plumb bob on the inside of the wall and you get a very nice finish, but if you go outside, the whole wall is out of plumb. So you have to do a very thick plaster, more than 1 inch sometimes. So with AC you can do a very thin joint, very beautiful construction. I'm just showing you a photograph which shows, so all the 3 pieces are cut to the same size and we are comparing weight. So about 2.5 kgs for red bricks, about 1 kg for AAC block, and fly ash brick even heavier than red clay brick. So by now we understand that if anything is heavier in weight, more heat will come inside, right? It will become uncomfortable to stay in a house. It will become more earthquake prone, that house. The cost of construction will go up, and that is how the density, the weight of the product is so important. We'll go to the next slide now. And therefore you see that fly ash bricks, they came to India very strongly around year 2000, but they are not there now, because customers realized that if you stay in a fly ash brick house, then it would be very warm to you, and compared to red clay brick. And even today customers get confused between AAC blocks and fly ash bricks. Both of them contain fly ash, right? But are AAC blocks fly ash bricks? No, 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 no. The main difference is aeration, the density. So we are talking aerated blocks density, how much? 650 kg per meter cube, even much lighter than water. If you take a AAC block and put it in water, it will float in water. So that low density we have got, and that is the magic, that is the secret of success for AAC blocks all over the world. Here I have, if you look at the last column, it is about the IS code, and very straightforward IS code we have got. Very nice IS code which tells us 5 properties. If you are going to order AAC blocks, what are the 5 properties you should check? So first is dimensional tolerance. So lengthwise, okay, maximum 5 mm allowed, but height and width, which is so critical to us, should not be more than 3 millimeters. Then about the strength, so you need to order a grade 1 block which will have a minimum strength of 4 Newton per mm square. The third point is density. As I said, the density should be less than 650 kg per meter cube. So it is a dry density. So you get a block on your side. What you do, take this block, put it in oven for 42 hours, remove all the moisture. Friends, AAC blocks are made in autoclave. autoclave in which lot of steaming is done. So because of this cellular structure, lot of moisture gets trapped inside. When AAC blocks come out of autoclave, they have got 25% moisture content. And when you leave them for 48 hours, they come to equilibrium with your environment. So they reach equilibrium humidity with the environment, and so there is no more loss of moisture after 48 hours. So we always request, wherever we advise, I advise to clients that don't use AAC blocks if you get them hot on your side. If the AAC block is hot on your side, this means the plant has dispatched them quickly. It happens, customer is shouting, his labor force is sitting, so the plant will dispatch. But if you don't want to have any cracking issue in your wall, leave them for 48 hours, let the humidity come at the equilibrium with your atmosphere, and after 48 hours you put them inside your wall. So that is about our dry density. Then we come to the most important value, drying shrinkage. Now friends, everybody pays attention to the compressive strength of your block, the density of your block, and everybody misses this point. So what is this? This is drying shrinkage. It is property of all the cementitious products. Look at our concrete roads, or look at the trimmings that we do. What we do? We cut grooves in the concrete. Why we cut grooves? Because we know the concrete is going to shrink and the concrete is going to crack, but it should crack at a predetermined location. So by cutting a groove, you are creating a weak zone. You are deliberately creating a weak zone in the concrete so that it cracks at that place. You look at our bridges, we have expansion joints which take care of expansion contraction, and also the shrinkage cracking is eliminated in our bridges because of these joints. So look at our external plaster of our buildings. In India, you go to any house and go to the outside wall, south side wall, southern wall and western wall. Our country is in the northern hemisphere, so the sun is always in the south. So in our Vastu Shastra we say don't do this in south, don't do that in south. South is a direction of Yama. It is not direction of Yama, it is direction of heat. So there was a scientific reason. So you do your guest bedroom in south direction, तो आपका guest within 2 दिन में भाग जाएगा. So that was what was the planning was. And as a result we face problem in our external plaster south and west, and it cracks. Why? Because of the shrinkage. All that heat coming on your plaster, the moisture loss takes place, the plaster shrinks and it cracks. So how do we protect it? You do a solid curing of 15 days. Cover the outside walls with a Hessian cloth for 15 days. And if you want to be ensured about a crack free plaster, so if you are a contractor, if you are a builder, you don't want the customer coming shouting after you, please cover it. In our concrete also we have got this plastic shrinkage and drying shrinkage, and this is a QCrete seminar, and QCrete is doing so much knowledge sharing, and I'm really thankful to them for doing this. And I know that every few days there is a great fantastic technical session on some aspect of our construction engineering, and they spread this knowledge, and we need to learn all these things like plastic shrinkage. If I'm doing my concrete, how I will cover it with plastic sheet within 1 hour of concreting so that there is no plastic shrinkage. Now you will say, Baba, why you are talking about concrete? I'm talking about shrinkage, drying shrinkage, which is an important issue, which has become a big issue when we don't handle it properly. So I don't want to bore you with calculations, but let's do one small calculation. So if you have got a calculator in your mobile, please just open it and we will see what this drying shrinkage means. Let's see that. So I have opened my calculator. Let's say the length of your wall is 5 meters. 5 meters is 5000 millimeters, right? So I have typed 5000. Now the drying shrinkage allowed by IS code is 0.05%. Very small value, right? But this means if your length of the wall is 5 meters and if you order good quality blocks, who have got drying shrinkage value not more than 0.05%, then how much your shrinkage will be? So 5000 multiplied by 0.05%, 2.5 millimeters. So your wall is going to shrink by 2.5 millimeters. Now a block of 4 MPa strength can just manage that. But if you increase the length of your free wall more than 5 meters, or let's say 15 feet, because on our side we talk in feet, so let's say 15 feet, don't do your wall more than 15 feet, then we need a vertical mullion, we need a vertical stiffener which will break the continuity of the wall. So what we do in roads, we cut the grooves. What we do in bridges, we provide an expansion joint. In AAC wall, very rarely it will be more than 5 meters in the residential construction. But sometimes there is some big hall in one of the flats where the continuous wall could be more than 5 meters. So please ensure that there is a vertical mullion. What is a mullion? It is just a precast concrete cast small beam, about 6" by 6" size. Place it so that the continuity of the wall is broken and the shrinkage remains within our control. In India, all the hot climate cities like Nagpur, then Ahmedabad, Indore, and Delhi. These 4 names I know very well because I was involved in many projects that there was cracking issue because substandard quality of AAC blocks was supplied. And this is where the correlation between your shrinkage value with your strength is. So please, anytime you are going to use AAC blocks, ensure that the strength is not less than 4. Higher the strength, lower will be your drying shrinkage value, right? So if you want to ensure that the drying shrinkage is less than 0.05, order the blocks of strength minimum 4 Newton per mm square. The last property is thermal conductivity. You don't have to test it as a customer, as a client. If the density is below 650, dry density below 650, your thermal conductivity will be less than 0.2, not even 0.24. So you are very safe about that. Just take care of your strength, density, and your drying shrinkage value. Now we will go to the next slide. And looking at the compressive strength of the block is also not very easy to calculate it. And let's see how we go ahead and have a look at that. So Anjali ji, can we go to the next slide? And we will list now the various advantages that you will get, and then you will compare it with the various properties of red clay bricks, and then you have to make that decision about whether for your next project you want to use AAC blocks or not. Because as I see it, in the Western India, Maharashtra, Gujarat, almost all the construction is today with AAC blocks. But if you go to rural places, this slide tells us about that, that there is a lot of load bearing construction, and IS code has given us a limitation that the internal wall minimum thickness has to be 150, external 200. Because remember, AAC blocks, okay, I'm saying a lot of good things, but then there are certain challenges while using it. Whenever it is a low self weight product and you are doing a load bearing construction, what is a load bearing construction? No beams, no columns, directly walls and roof on that. So all that roof load, it comes on our walls. So walls need to have some stability, right? And with red clay bricks there was no question because high self weight. So the disadvantage becomes advantage in this case. So any load bearing construction, ensure that you have minimum 200 mm outside wall and 150 mm inside wall. This our IS code is saying while using AAC blocks. And for non load bearing structure like our RCC, your internal walls can be 100 mm and outside walls can be 150 millimeters. Okay, let's go ahead. And as I was saying, in the Western India, almost all the construction today is with AAC, and very few pockets you will find red clay bricks being used. Why? Because of all these key benefits. So the first one we saw, lightweight, means lower concrete and steel, economical construction. Aeration, it gives great fire resistance. Suddenly last 2 years AAC blocks have become very popular in Gulf. Why? Because fire resistance is a very important property for them in the Gulf, and no other product gives you fire resistance like AAC blocks give you. Then you have superior thermal efficiency. Just let me give you an example. Suppose you want to construct your own bungalow in a very hot city, let's say like Nagpur, where the atmospheric temperature goes beyond 48 degrees sometimes. So you decide to have your outside wall thickness 9-inch with AAC blocks because you want to keep the heat away. Now the same house, if you do with red clay bricks, you will need 14-inch wall thickness to give you the same comfort, to give you the same thermal insulation in the hot climate, right? So 9-inch against 14-inch. This is easier to understand, right? Instead of 0.9 thermal conductivity and 0.024, 9-inch against 14-inch. And I have a book on AAC blocks. It was published by Amazon, and there I have given a detailed calculation how to arrive at wall thickness for your comfort compared to red clay bricks. How to use that thermal conductivity value in the calculation. Okay, but larger blocks. Why larger blocks? Because wet is less. So instead of doing a chota wala brick, you can do a big 2 feet block. Faster speed of construction, very less joints. You need very less mortar masala to be put inside the joint. About low environmental impact, very important matter, and we will go to the last slide and see it. Superior sound insulation. So the sound will not travel to your neighbor, and you can fight with your wife at top of your voice, but your neighbors, they will not be able to hear about it. And of course I have spoken about better earthquake resistance. Let's go to next slide. We have to cover still a lot of material, and running behind the time, sorry for that. So understanding fly ash. Now 65% material in our AAC is fly ash. Friends, we know that when we did our cement manufacturing over last 50 years, earlier it was 33 grade of OPC, right? Then we changed from 33 to 43, from 43 to 53 grade of OPC. Now as we went on increasing the strength of our cement, the nature gave us a side effect. We all know that if you try for speed, there is always some side effect. If you use chemical fertilizers, the soil will lose its value. If you use strong allopathic medicines, there would be some side effect, right? So the same side effects started coming in our concrete in the form of calcium hydroxide, free hydroxide. So you want to look at with your eyes, you can look at your freshly done plaster and you will find white patches on that. If you go to your retaining wall, you will find the white line coming down after every 3 meters. All this white material is the gift from OPC to us. 25% calcium hydroxide getting formed in the hydrated CSH gel. And so fly ash came in, and fly ash, what it did, it converted this calcite again secondary CSH gel. So therefore all the construction today, most of the concrete that you will be using on your sites will contain GGBFS or fly ash, right? And with these two materials coming in, we get the durability of our concrete. So so therefore this is just one example. Colosseum in Rome, 3500 years ago, constructed with fly ash. So they had volcanic ash, they never had fly ash there, but the property was same. So fly ash has got lot of reactive silica, reactive alumina, and therefore we add it and we give 100-year life to our construction. So therefore fly ash is an important property of AAC blocks. Today Burj Khalifa from Dubai, they used 25% fly ash in their concrete. They imported from India. I was part of the mixed design team in Burj Khalifa as an advisor, and for them the cost of fly ash is 50% more than the cost of their local cement. So for them it is an invaluable material. importing in their country. But we look at fly ash as a waste product. It is not a waste product. It is reactive silica and alumina, which is going to give lot of strength to your concrete, lot of durability. Okay, so this is our typical surface of a AAC block. It should have this textured surface so that plaster will hold it properly. Let's go ahead to the next slide. And this plaster holding is important because AAC block is a factory finished product, right? And therefore there is a possibility that if the surface is too smooth, the plaster may fall down. And these are some of the customer pain points with various AAC brands which are there today. First one, I said cracking of wall, drying shrinkage value should be less than 0.05%. Second is breakages on site. When the truck reaches your site and if the packaging is not done properly in the truck, there can be breakages. So check the packaging if you are getting a lot of broken blocks. Plaster not holding, order the blocks which have got textured surface so that the plaster will hold to them. And of course inconsistency in the quality of AAC blocks. So many plants have got ISI mark today, and each block you make it mandatory to your supplier that it should have ISI mark. I don't want to go again now deep into clay bricks pain point. We have covered most of them, but first one, thermal conductivity, we have covered. Breakages, you know, when the red clay bricks are unloaded on the site, we get a big heap of broken bricks, you know, so that's normal, but we accept it. We say that okay, bricks hai, aise to hoga hi. Speed of construction with AAC, you can do 10 by 10 wall in 50% amount of time compared to clay bricks. Saving in water, no curing required. The chemical mortar that you get for fixing AC blocks, it is cheaper than using sand and cement, and curing not required because it has got polymers in it. So totally we get about 45-50 rupees reduction per square foot in construction cost. And of course fire resistance, I have spoken, AAC blocks have got 4 hours and bricks have got 2 hours. This is important slide for anyone who wants to learn how to do the masonry. You need to have a starter beam, you need to do the surface wetting of blocks. Friends, on each of these points I have got detailed YouTube videos how to do the construction. So you can go to YouTube and you can visit my channel and you can check all these points, how to fix the vertical stiffener, how to treat the top joint between the wall and the beam. And let's go to the next slide, because on the next slide we are going to slightly talk about this particular point quickly before we go to our question answer session. Because as you are going ahead and doing layer by layer of AAC and you reach the beam bottom, unfortunately our beam on top, let's go to the previous slide. Our beam on top, it has always some deflection at the center, right? And that deflection causes shock waves in our wall. So we pack it with aggregate stones and then we fill the mortar. Technical point too much for you to imagine and understand? Don't worry about it. If you want to understand the second main reason to stop cracking of AAC block wall, this is the second reason: not treating the top joint properly. First reason, drying shrinkage value, right? So order the blocks more than 4 MPa strength, one problem gone. Second problem, workmanship on site. Do go to my video, and it is a complete 10-15 minute video how it has to be done step by step. I'm sure if you have any practical issues, you will be able to solve them after watching that video. Okay, we can go to the next slide now. So in the next slide, we saw that there are 2 pans which a mason has to carry. The red pan is for carrying the aggregate pieces to do the packing thing. You know what our mason friends do? They go up to the beam bottom and they quickly fill the mal masala there. And from outside, you will never know whether he did the aggregate packing inside or not. So ensure that they carry in this red pan aggregate pieces 10 mm down. You know, they have to just keep some pieces, and every 6 inch they have to add 1 piece aggregate packing. Let's go ahead. So friends, then we look at the mortar, how we apply the mortar. You see how beautiful the work is done, just 3 millimeter joint. It saves you cost and also gives durability to your wall. We can go ahead to the next slide. So these are a lot of mortars available. Even big companies like Ultratech, QCrete, they all have mortars in their own brand. You can take any mortar from that. Even Weber has got Saint Gobain their own mortar in the market. The strength should be minimum 12 Newton per mm square. It should be a flowable mortar. The mason should feel that it is like a makhan when he is applying that. It should be non-shrink. Of course, curing is not required. Why? Because there are polymers inside the mortar. And the typical area coverage per bag of 40 kgs, you get 170 square feet. Let's go ahead to the next slide. So friends, when you use AAC blocks, the central government came up with a notification which helped the spread of alternative technologies. In the year 2000, central government has a notification that the use of clay bricks is banned anywhere 300-kilometer radius of any thermal power station, which means basically all over India, because we have got more than 150 thermal power stations in our country. You cannot manufacture red clay bricks, you cannot sell them, you cannot use them. Why? Because we use topsoil for making red clay brick. You know, nature takes 500 years for 1 inch of rock, converting it into topsoil, and we remove in 30 minutes, and then that results into deforestation, surface water runoff, and all the environmental problems. So therefore friends, those days are gone that you can take fresh material for your construction from the nature. No, we have to look for recycled technologies like fly ash, like GGBFS, like plastic waste. I am telling you, after 10 years, even you are not going to get your aggregates to produce your concrete. And companies like QCrete, who are always at the forefront, they are continuously doing lot of R&D about what next, what after 10 years is going to happen, and how we can give the best service to our customer. So friends, environmental protection becomes very important, and all of us have to move towards a green earth by using the technology, green technology in all aspects. Thank you so much, and I'm sure you have many questions, and let's take them. So I request Anjali ma'am to ask, to just say it aloud if there are any questions.
Hello.
Yes, sir.
Some questions I will start asking. Which Anjali, you can talk now. You can take the questions. Hello.
Yes, sir.
Yeah.
So the first question is, in my construction, I seen every 4 to 5 feet, they will make a 4-inch wide and 6-inch wide of beam on AAC block. And the question was asked by Khaja Constructions.
I have not understood the question. 6 feet wide what?
So 4 to 5 feet, I've seen 4 to 5 feet, they'll make a 4-inch wide and 6-inch wide of a beam on AAC block. Is it correct way of doing?
Kaushik sir, I'm not able to understand the question, what the questioner is wanting to ask.
I am also not able to understand. Anjali, slowly can you read?
Can you speak bit loudly, Anjali ji?
Sure, sir. Sir, the next question is, can we go for exterior walls without plastering?
Yes.
If
So,
not, can we apply texture directly on block? And that was asked by Dr. S.P. Anju.
So, sir, AAC block doesn't permit seepage of water, right? So there is no capillary action. We have done demonstrations so many times in many exhibitions, making one wall with bricks, one wall with AAC, right? So two walls next to each other. And what we do is we continuously put water through a spray for 72 hours non-stop. And in a brick wall, within 30 minutes, you see the water coming from inside. Because there is capillary action. In AAC, no capillary action. So the water doesn't travel. But if the joints are not done properly, you can have a problem. So we have done a construction for Mumbai Metro in Mumbai. And for that, on one wall, we have done pointing. So no plaster, but just pointing. It looks beautiful and no plaster required. Even in Mumbai rain, can you imagine? Without plaster, the wall stands. So yes, it is possible, but you have to take so much precaution.
Thank you, sir. The next question is why still AAC blocks is not popular in India? And the question was asked by Abin Thomas.
Yes, thank you so much for this question. As I said, red clay bricks, 5,000 years. They are in our genes, right? And AAC blocks came 10 years ago. So we always keep a track of this number, In the year 2015, 1% of red clay bricks was replaced by AAC. Today it is 20% at India level. So there is a 20 times jump in AAC sale in last 7 years. And it is expected that this jump will continue and probably we will reach somewhere around 60-70% replacement for red clay bricks over next 10 years. But this is just a projection. But just let me tell you one thing before I stop this. The most used material on earth is water. We all know about that. Do you know the second most used material on earth? It is our concrete, the second most used material on the earth. After concrete, the second most used construction material on earth is AAC blocks. It is written in the future. It is not going to change. In few areas there is resistance. In few areas there are a lot of question marks in the mind, but it is going to happen. You know why it is going to happen? Number one, you are not going to get any other fresh product like red clay bricks from the nature. It is the law is going to be stronger and stronger on one side. On second side, AAC blocks, they save lot of money. And finally, if the product doesn't save money, will the builder use it? No, it can be gold, but builder will not use it. He will resist it. So there is lot of interest also from the building community because they immediately calculate and see lot of saving. On the third side, quality wise, you have got nothing to complain as long as you take certain precautions. That is with every material, isn't it? Even with our concrete, we have to take precaution. If you don't do the curing, the result is bad. So you take precaution, it saves money, the product is great, and the environmental laws are going to be stronger and stronger. So I feel that in next 10 years, at least 50% of India would be covered with AC blocks. Okay, next question.
Thank you so much, sir. The next question is it okay to use a regular cement mortar for joints? Can we go for exterior walls without plastering? If not, can we apply texture directly on block? And that was asked by Dr. S.P. Anju.
Yes, so first part I answered. No plaster outside, you will have to do pointing. The second part was why you want to use cement and sand. The problem with cement and sand is the sand particles, they will be more than 2 millimeters and your joint thickness will be more than 4 millimeters. And we want to keep the joint as thin as possible. We want to save cost on one side by thinning the joint, and you want to have a perfect masonry in line and level. So, with red clay bricks, it is okay to use sand because the bricks are out of shape. And anyway, you need 15 millimeter ka joint at least. to cover up the differences in the bricks. In AAC block, that's not the case. Okay, so if you insist, I want to use it, I will say, okay, use it, cement and sand, but not advisable. Use these ready-made mortars, fantastic quality, no variation. You don't depend on the site mason, kitna cement dala, how much water he put in. It's very straightforward to use the mortar. So that's what I would.
Thank you so much, sir. The next question is, what is the problem with formed concrete blocks which are not cooked at high temperature? And that was asked by Sukumar.
So the audio is not working. Audio is not working.
Sorry. I was on mute. So this CLC technology came, foam concrete technology, in the year 2008-2010, and within 5 years it left our country. There are very few plants because it is very difficult to do a CLC block, to do a foam concrete. You need so much high amount of cement and lime, so the cost of production goes up, and the density it is very difficult to maintain. If you do as lightweight as AAC, then the corner breakage starts. So the reason is there is no autoclaving involved, and therefore you have to do all the manual curing for 10 days, 15 days. This is a very small setup. I would say like a very small, manual industry it is, and against the industrialization of AAC, against the mechanization of AAC, the CLC technology cannot withstand the quality, and therefore a CLC manufacturer always has to sell his blocks to grade B clients who are okay with an inferior product. You can never go to a grade 1 client and sell your product. So CLC came, and unfortunately it left as well.
Thank you so much, sir. The next question is, in Middle East countries, they sandwich EPS strip. How do you compare with AAC blocks? And that was asked by Mahesh.
Sandwich blocks are, there are few plants, but again the issue is mass production. You can't do a mass production. Problem number 1. Problem number 2 is the material that you are using for the sandwich blocks. It is not environment friendly at all, even to manufacture it. So there is lot of resistance from green technologies. So you get a thermal insulation which is somewhere close, but not great as AAC. So with these 3 aspects, that technology, even there were some friends who tried to bring it to India, but they couldn't do the mass production. All these products you need to do mass production. A good AAC plant produces 1000 cubic meter per day, huge quantity. 30,000 cubic meter per month you are able to sell, and very soon you will find that AAC panels are going to come. So blocks will go away, and that is a technology will come. So directly you will have a panel which you will erect, and even no need for plaster. Directly do the painting on it. Faster speed of construction, but that panel will need reinforcement. So although all over China the panels are being used, we are 10-15 years behind China every time, and behind Europe and America. So I'm sure in next 5 years panels will come in a big way in our country.
Thank you so much, sir. The next question is, many of AAC blocks get failure in tube drop level checking. Why such unstandard size even when the construction we seen in complete of outer wall that looks like undulating of fed by checking center line distance of column outer to outer?
I'm sorry, I don't agree with this remark, because you get the most accurate construction with AAC compared to red clay bricks. Okay, there can be a tolerance of 2 millimeters in the width, but not more than that. And in case of red bricks, I see that you have to do a plaster of 1 inch, more than 1 inch many times to cover the irregularities. But with AAC, 10 millimeter, 12 millimeter external plaster, that's all you need, because the deformation will not be more than 2-3 millimeters. So I'm sorry, but I don't agree with this observation. Maybe sir, you have seen it on some site somewhere, but routinely all over India you will find very nice line and level construction with AAC blocks.
Thank you, sir. The next question is, AAC blocks can be used for load-bearing walls.
You have to be very careful while using for load bearing. Thank you for asking this question. I showed one slide.
And this question was asked by engineer Nilakanta.
Okay, Mr. Hemakanta. So you have to be careful. IS code has given the width of the block if you want to use it for load bearing, right? 150 minimum internal wall, 200 minimum external wall. And if you want to do the construction below the ground, I will say don't do it, please, because there is lot of horizontal pressure, lateral force on our walls below the plane coming from the soil, and you need self weight, right? So please, for any work below the plane, use solid concrete pillars.
Thank you so much, sir. The next question was asked by Khaja Constructions. And the question is, actually fly ash is a little part in cement, but why fly ash is being used more in AAC blocks? Is it good for heat of hydration or not?
So I mentioned in one of my slides, fly ash has lot of chemical properties like reactive silica and reactive alumina. That gives a long life to our construction. All over the world, this material is being used to improve the life. Why? Because the chemical properties and the way it combines with our OPC. So our IS code also allows us to use fly ash up to 35% in our concrete, right? So that is a strong reason why fly ash, most of your future construction is going to come from fly ash. Why? Because in our country, millions of tons of fly ash is lying in various power stations. And for construction guys, this is like gold. I will not be wrong if I say that after 10 years, probably you will find aggregates made from fly ash when you can't get your natural aggregates, when some ban comes on mining for aggregates, right? So fly ash is a wonderful material. Yes, we use it to reduce heat of hydration in concrete as well, but it doesn't mean reduce strength. You get fantastic long-term strength when you use fly ash in concrete as well, right? So I think we all should use it.
Thank you so much, sir. The next question is asked by Dr. B. Kamesha Rao. The question is, can we do autoclaving of cellular lightweight blocks?
Dr. Rao, fantastic question. Many guys have tried that, but they are not successful in doing that, because this autoclaving is a complex process. As I said, very risky thing if you don't do it correctly, and due to various reasons, it has not been very successful with CLC. If somebody wants to do autoclaving at that level, the way it is done in AAC, just to tell you, cost of one complete autoclave setup is more than 1 crore rupees. One autoclave, I'm saying. And normally there are 5 to 7 autoclaves in AAC plant. So it's a massive investment. And the CLC guys cannot do that kind of investment when your plant cost is 50 lakh rupees. So the whole CLC plant is 50 lakh against each autoclave costing more than 1 crore of rupee. So therefore it is much safer not to do trial and error, but shift to AAC and have your whole setup in a scientific manner. But yes, to answer your question honestly, I have not seen a single guy. There are many guys who have tried low pressure autoclave with steam chambers made from bricks, but all disaster. You need an autoclave with 12 bar pressure. Otherwise, you will not get that strength, and you can't do it at a cheap price, you know. So that's the problem. Any other question?
Thank you so much, sir. Next is a question asked by the water ratio. We have a question by Praveen Nigam.
What is the question?
The question is, what would be the water ratio for joining mortar?
Water ratio for jointing mortar.
Yes, sir.
So typically in a 40 kg bag, you add about 5 to 7 liters of water by volume. But what we do is we give volumetric measurement to our site guys, because they cannot really measure it. So what we say is volumetric, 1 part to 3 part, right? So 3 parts of mortar, 1 part of, so you have a dabba on site, you take 3 dabbas of mortar and 1 dabba same of 3 dabbas of mortar and 1 dabba of water. You might find this very crude way of explaining, instead of saying 5 liters to 40 kgs, but this is a simple way of explaining the site mason who may not understand liters and it will be difficult for him. So volumetrically, it is 1:3. 1 part water, 3 part mortar.
Thank you so much, sir. The next question is asked by Mr. Murugan, and the question is, use of huge amount of heat to make AAC blocks, does it not make it energy intensive program, and does it not make it an ungreen product?
Thank you so much for asking this question, and there is a lot of study done on the CO2 emission while making red clay bricks and while making AAC blocks. So 0.9 tons of CO2 is emitted when you do 1 cubic meter of red clay bricks. And CO2 emission, yes, it is there with AAC because we are using steam, but it is only 0.2. So there is a lot of difference, almost 3.5 times less CO2 is emitted. You know, any construction product, you start from cement, steel, even our aggregates that we do, there is always energy involved, which is also involved in AAC, but it is much on the lower side than running your cement ka, than running your eat ka bhattas. So all these brick bhattas, what they do, it is unorganized operation where you there is no efficiency from fuel being derived. Whereas in case of AAC, it is a fully mechanized operation. You try to use every ounce of heat which is in the autoclave. So what you do, once the autoclave is done, 12 hours is over, you transfer that steam to the next autoclave. You lose 20%, but 80% is reused. Again, you transfer 80%. So a lot of heat is extracted continuously till that steam loses its value completely. And therefore, there is a huge difference in CO2 emission compared to red bricks.
Thank you so much, sir. We are done with the questions, sir.
Yeah, thank you, sir. Lot of questions. You are tired taking a lot of questions from the participants, actually.
About AAC, I am always fresh, you know. No problem.
You're passionate speaks, actually. Yes, sir.
Yes.
We have come to the end of an interesting topic, inside story of AAC Blocks. Really, it was an interesting story by our speaker, Mukund Joshi. The concept of AAC was well explained, its manufacture, strength, and its uses, and also all the questions was fired at the speaker. He took it very well, and I hope most of the things has been cleared by him, actually. Thank you very much, sir.
for this wonderful session. Thank you, sir.
Thank you very much.
I thank Chairman and EC members of Indian Concrete Institute Mangaluru Center for associating with QCrete for successful conduct of QCrete webinar series. Actually, I thank VR Kaushika, Director of QCrete, and Anjali for coordinating and successfully conducting the webinar series. And I thank all the participants, in spite of being a Saturday and a beautiful cricket match going on 2020. We have a good number of participants attending to the topic what we had selected. Thanks a lot for coming and attending to this webinar series. Actually, I am Shelias Fernandez, QCrete Ready Mix India Private Limited, signing off from this QCrete webinar series, only to come back again with the next webinar series. Thank you all. Thank you very much, sir.